Hello, in this lecture we will find the length of chord AB. In the drawing we have a semicircle. Inside this semicircle we have 3 circles, and those 2 small circles are identical, and in the middle we have the middle circle, and this middle circle is tangent to the semicircle at point O. Point O is also the center of the semicircle, and we know that PQ equals to 8 units, and actually PQ is the diameter of this semicircle, and the radius, the diameter is twice as large as the radius. So if the diameter equals to 8 units, then the radius of this semicircle will be equal half of it, that is to say it will be equal to 4 units. So PO will be equal to 4 units. This is the radius of the semicircle, and OQ will be also equal to 4 units. It is also the radius of this semicircle, and OX will also equal to 4 units. It is the radius of this semicircle, but OX, it is not only the radius of this semicircle, but it is also the diameter of this middle circle. So the diameter of this middle circle OX equals to 4 units. Therefore the radius of this middle circle will be equal to half of it, that is to say the radius of this middle circle will be equal to 4 over 2, that is to say it will be equal to 2 units. So CX, the radius of the middle circle, will be equal to 2 units, and OC, that is also the radius of this middle circle, will be equal to 2 units. We will define the center of this small circle as point M. Then we will join together the 2 centers M and C of those 2 circles by a straight line. So actually MC is the distance between the centers of those 2 circles, and the distance between the centers of 2 circles when they have an external notch between them, like in this drawing. The small circle is tangent to the middle circle at this point. We define the touching point between the 2 circles as point Y. So those 2 circles have an external notch between them, therefore the distance between their centers will be equal to the sum of the lengths of their radiuses. If we define the radius of this small circle as R, then NY will be equal to R. And we know that the radius of the middle circle, that is to say YC, equals to 2 units, so YC will be equal to 2 units. So in total, the distance MC between the centers of those 2 circles will be equal to R plus 2. So MC equals to R plus 2 units. We will define the touching point between the tangent PQ and this small circle as point N. Point N, it is actually also the point of tangency of tangent PQ with this small circle, and we will join together points M and N by a straight line. Actually MN it is the radius of this small circle, that is to say it equals to r, and we have this radius mn. It is drawn to the point of tendency, that is to say it is drawn to point n, that is the point of tendency of tangent PQ with this small circle. Therefore, the tangent PQ will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Because whenever a radius of a circle is drawn to the point of tangency, then that tangent will be perpendicular to that radius. In this case, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, the radius CO of the middle circle is drawn to the point of tendency, that is to say, it is drawn to point O, that is the point of tendency, of tangent PQ with this middle circle. So because of the fact that the radius CO is drawn to the point of tendency, then the tangent PQ will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. In the next step, we will draw perpendicular from point M to OC. So actually, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the touching point between the perpendicular from M to CO as point D, and we will also define this point as point E, and then I will draw the quadrilateral MNOD and the right triangle MDC in a new page. And we have also another thing that is given to us, that AB, this chord AB that we are looking for, is parallel to PQ. To PQ, that is the diameter of this semicircle. So I draw again the quadrilateral MNOD and the right triangle CDM. We know that PQ is parallel to AB, and we have a rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. According to rule number 1, corresponding angles between parallel lines are equal to each other. So I will read rule number 1 again. Rule number 1 states that corresponding angles between parallel lines are equal to each other. So actually here we know that AB is parallel to PQ. It is given us the question that AB is parallel to PQ. And according to rule number 1, the corresponding angles that are located between the parallel lines AB and PQ are equal to each other. So those two angles, they are corresponding angles that are located between the parallel lines AB and PQ. So this angle that equals to 90 degrees, it is a corresponding angles, and this angle angle CEY is a corresponding angle, and according to rule number 1, those two corresponding angles are equal to each other. That is to say, "90 degrees equals to angle CY. 90 degrees equals to angle CY. The two corresponding angles, one of them is 90 degrees, and the other one it is angle CY, and those two corresponding angles are located between the parallel lines AB and PQ. Therefore, according to rule number 1, the angle that equals to 90 degrees equals to angle CY. This is according to rule number 1. Or in other words, angle CEY equals to 90 degrees. Angle CY is a right angle, it equals to 90 degrees. So we can write here that this angle, angle CY, is a right angle, it equals to 90 degrees. Likewise, those two angles are also corresponding angles that are located between the parallel lines AB and PQ, therefore they are also equal to each other. So this angle is angle that equals to 90 degrees. And this angle is angle CEB. And according to rule number 1, those two corresponding angles are equal to each other. That is to say, angle CEB equals to 90 degrees. So this angle, it is also a right angle, that is to say it equals to 90 degrees. Angle CEB is a right angle, it equals to 90 degrees. Okay? So, we know that here we have quadrilateral MNOD, this quadrilateral, so we will focus on quadrilateral MNDO. On quadrilateral MNDO, we have 3 right angles, 1, 2, 3. And according to rule number 2, the sum of the angles in any quadrilateral equals to 360 degrees. The sum of the angles in any quadrilateral equals to 360 degrees. Okay, I'll read rule number 2 again. Rule number 2 states that the sum of the angles in any quadrilateral equals to 360 degrees. Therefore, the sum of the angles in quadrilateral MNDO equals to 360 degrees. So in quadrilateral MNDO, according to rule number 2, the sum of its angles equals to 360 degrees. And quadrilateral MNOD is 3 right angles, 1, 2, 3. And the sum of 3 right angles is 90 times 3 equals to 270 degrees, plus the size of this angle. We define this angle as angle X. So plus the size of angle X must be equal to 360 degrees according to rule number 2, that the sum of the angles in any quadrilateral equals to 360 degrees. So especially in triangle in quadrilateral MNTO, the sum of its angles equals to 360 degrees. That is to say, the sum of the three angles that in total are equal to 270 degrees plus the size of the fourth angle, that is angle X, must be equal to 360 degrees. Here we will subtract 270 degrees from this equality, and we will get that angle X equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle X, it is a right angle, it equals to 90 degrees. So we can write here that angle X is a right angle so as you can see from the drawing, quadrilateral MNOD has four right angles. And we have rule number 3. Rule number 3 states that any quadrilateral that has four right angles must be at least a rectangle. Any quadrilateral that has four right angles must be at least a rectangle. It must be at least a rectangle, if not a square. So I will read rule number 3 again. According to rule number 3, any quadrilateral that has four right angles must be at least a rectangle, if not a square. Okay, so we will relate to quadrilateral MNOD as a rectangle. And we also have rule number 4. According to rule number 4, the sum of the angles, according to rule number 4, the opposite sides of a rectangle are equal to each other. The opposite sides of a rectangle are equal to each other. So I will read rule number 4 again. According to rule number 4, the opposite sides of a rectangle are equal to each other. And here we know that MN is the radius of the small circle, that is to say MN equals to R. So we can write here also that MN equals to R, and according to rule number 4, that the opposite sides of a rectangle are equal to each other, we will get that MN equals to DO, Mn equals to DO according to rule number 4 that the opposite sides of a rectangle are equal to each other. I'll repeat again. Mn equals to DO according to rule number 4. But we know that Mn equals to R. So we know that Mn equals to R. So from this equality, R equals to Mn equals to DO, we will conclude that that DO equals to R2, that DO equals to R. Okay, from this equality we will conclude that DO equals to R. So here DO equals to R. DO equals to R. And what is the value of CO? So you can see from the original drawing, CO is the radius of the middle circle, and the radius of the middle circle equals to 2 units. So CO equals to 2 units. So we can write here that CO equals to 2 units, and we know that DO equals to R. So CD, so you can see from the drawing, CD equals to CO minus DO. Again, CO minus DO equals to CD. CO minus DO equals to CD. I write it down. I will repeat again. CD equals to CO minus DO, but we know that CO equals to 2 units and DO equals to R. So in total CO that equals to, in total CD that equals to CO minus DO will be equal to 2 minus R, because CO equals to 2 and DO equals to R. That is to say CD equals to 2 minus R. So we can write here that CD equals to 2 minus R. And we have already found out that MC, that is the distance between the centers of the small circle and the middle circle, the distance between the center of the middle circle and the small circle equals to R plus 2. So MC equals to R plus 2, and CD equals to 2 minus R. So we will focus on the right triangle, triangle CDM. On the right triangle, triangle CDM, according to the Pythagoras theorem, that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the right triangle, triangle CDM, is MC, so the square of the hypotenuse is MC squared. MC squared equals to the sum of the squares of the perpendiculars, equals to CD squared plus MD squared. So I'll repeat again. If we relate to the right triangle CDN, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say MC square equals to CD square plus MD square. But we have already found out the value of MC. MC equals to R plus 2. If MC equals to R plus 2, then MC square will be equal to R plus 2 square. CD equals to 2 minus R, therefore CD square will be equal to 2 minus R square plus MD square. So in total we got that MC square is R plus 2 square, CD square is 2 minus R square, and MD square is MD square. We will open the brackets of equation number 1 in both sides of equation number 1. We will get that R plus 2 square equals to R squared plus 4 plus 4R, and it is equal to 2 minus R square is 4 plus R square minus 4R plus MD square. So here we have R square on both sides of equation number 1, so R square will get cancelled. And we also have 4 in both sides of equation number 1, so 4 will also get cancelled. And what is left from equation number 1 after we cancelled those expressions? What is left, actually what is left in this side of equation number 1 is actually 4R equals to, here in the other side of equation number 1 we have minus 4R plus MD square here we will add 4R to this equation number 1, and we will get that 4R plus 4R is 8R. 4R minus 4R is 0, and what is left, it is actually MD square. So we found out that 8R equals to MD square. Here we will take a root out of this equation number 1, and we will get that MD equals to the square root of 8R. MD equals to the square root of 8R. We know that 8 equals to 4 times 2, so we'll substitute 8 by 4 times 2 in this equation number 1, and we will get that according to equation number 1, MD equals to the square root of 4 times 2 times R. So we got that MD equals to the square root of 4 times 2 times R. The square root of 4 is 2. So I'll write it down. In total we will get that, according to equation number 1, MD equals to 2 times square root of 2R. So we actually found out that MD equals to 2 times square root of 2R. So we can write here that MD equals to 2 times square root of 2R. Okay? But we also have rule number 4 that says that the opposite sides of a rectangle are equal to each other. That is to say, MD equals to NO according to rule number 4. MD equals to NO. I will repeat again. MD equals to NO according to rule number 4. But we have already found out that MD equals to 2 times square root of 2R. So we can write here that MD equals to 2 times square root of 2R. And from this equality, we will conclude that NO also equals to 2 times square root of 2R. NO equals to the square root of 2 times square root of 2R. So we can write here that NO equals to 2 times square root of 2R. In the next step, we will join together points M and O by a straight line. We will do the same thing in the original drawing. We will join points M and O by a straight line. And we will also join together points A and M by a straight line. What is AM? AM, it is actually the radius of the small circle. That is to say, it equals to R. So we know that AM equals to R. And what is AO? AO is the radius of the semicircle. That is to say, it equals to 4 units. So AO, the radius of the semicircle, equals to 4 units. And what is the length of MO? MO, from the drawing you can see that MO equals to AO. AO minus AM equals to MO. AO minus AM equals to MO. I will repeat again. From the drawing you can see that MO equals to AO minus AM. But we already know that AO equals to 4 units and AM is the radius of the small circle, that is to say it equals to R. So in total we found out that MO equals to 4 minus R. MO equals to 4 minus R. So here we can write down that MO equals to 4 minus R. And here also we found out that MO equals to 4 minus R. So in the next step, we will focus on the right green triangle, triangle M and O. On the right green triangle, triangle M and O, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, so in the right triangle, triangle M and O, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse in the right green triangle, triangle M and O is MO, so the square of the hypotenuse is MO square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to MN square plus NO square. So I will repeat again. In the right green triangle, triangle M and O, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, MO square equals to MN square plus NO square. But we have already found out that MO equals to 4 minus R. If MO equals to 4 minus R, then MO square will be equal to 4 minus R square. And it equals to Mn square. Mn equals to R, so Mn square will be equal to R square plus NO square. NO equals to 2 times square root 2R. Therefore, NO square will be equal to 2 times square root of 2R square. So in total, we found out that 4 minus R square equals to R square plus 2 times square root of 2R square. Here we will open the brackets of both sides of equation number 2, this equation, and we will get that 4 minus R square equals to 16 plus R square minus 8R, and it equals to R square, and 2 times square root of 2R square is 8R, because 2 square is 4, and the square root and the square root will be cancelled, and we will get that 4 times 2R equals to 8R. So here we have R square in both sides of this equation, equation number 2, so R square will get cancelled. In the next step, we will add 8R to this equation, equation number 2, and we will get that 16 minus 8R plus 8R is 0. 16 equals to 8R plus 8R is 16R. So we found out that 16 equals to 16R. Here we will divide this equation, equation number 2, by 16, and we will get that R equals to 1 unit. R, the radius of the small circle, equals to 1 unit. So we can write here that R equals to 1. Here also R equals to 1. And CD that equals to 2 minus R, it is actually equals to 2 minus 1. That is to say, CD equals to 1 unit. CD equals to 1 unit. So in the next step we will focus on two triangles. We will focus on the right triangle, triangle CYE, green triangle, triangle CYE, and we will also focus on the right triangle, triangle CDM. And we will prove that those two right triangles are similar to each other. Okay? So in the right triangle, triangle CYE, this green triangle, and the right triangle, triangle CDM, the bigger triangle, first of all, we know that those two angles, they are equal to each other, they are both right angles. So here, this angle is actually angle CEY, angle CEY, in triangle CEY, equals to angle CDM, in triangle CDM, and they are both equal to 90 degrees, they are right angles. So actually angle CEY equals to angle CDM, and both angles are right angles, they are equal to 90 degrees. We also know that this angle is a common angle. It belongs to both triangles. Angle C belongs to the green triangle, triangle CYE, and angle C, this angle also belongs to triangle, the right triangle, triangle CDM. So we can write down that angle C equals to angle C. It is a common angle that belongs to both triangles. So angle C equals to angle C is a common angle that belongs to both triangles. And those two angles, they are also equal to each other according to third angle theorem. So this angle, angle CYE, equals to this angle, angle CMD, and those angles, they are equal to each other according to third angle theorem. I will repeat again. Angle CY in triangle CYE equals to angle CMD in triangle CMD, and those angles are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. In those two triangles we have they are the first pair of angles, and of angles that congruent. They are both right angles, and this is the second pair of angles that congruent. This angle equals to itself, So we have in those two triangles two pairs of angles that can go into each other. Therefore, according to third angle theorem, the first pair of angles must also congruent. That is to say, angle CYE must be equal to angle CMD. Okay, that is the meaning of third angle theorem. So we actually proved that all three angles on the green right triangles congruent to all three angles in the right triangle, triangle CDM. Therefore, we proved the triangle CYE, the green triangle, is similar to triangle CDM according to angle similarity rule. So I write it down. We actually proved that the green triangle, triangle CYE, is similar, this is the sign of similar to triangle CDM, and they are similar to each other according to angle similarity rule. I will repeat again. We actually proved that triangle CYE is similar to triangle CDM according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle congruent to all three angles in another triangle, then you proved that those two triangles are similar to each other according to angle similarity rule. And from the fact that triangle CYE is similar to triangle CDM, we will conclude that the following equality is true. We will conclude that CE over CY in the green triangle, triangle CYE, equals to CD over CM in triangle CDM. So I write it down. We will conclude that CE over CY in triangle CY equals to CD over CM in triangle CDM. I will repeat again. From the fact that triangle CY is similar to triangle CDM, we will conclude that CE over CY in triangle CEY equals to CD over CM in triangle CDM. So actually CE over CY. What is the value of CY? As you can see from the drawing, the value of CY equals to the radius of the middle circle. That is to say, it equals to 2 units. So CY equals to 2 units, and it equals to CD. What is the value of CD? CD equals to 1 unit, and over CM. CM equals to R plus 2, but we have already found out that R equals to 1, so R plus 2 equals to 3 units, so CM equals to 3 units. So in total, we found out, according to equation number 3, that CE over 2 equals to 1 over 3. Here we will multiply equation number 3 by 2, and we will get that CE equals to 2/3. CE equals to 2/3. So here we can write down that CE equals to 2/3. CE equals to 2/3. And what is the value of DE? The value of DE, it is actually CD minus CE. CD minus CE equals to DE. CD minus CE equals to DE. Again, DE equals to CD minus CE. That is to say, DE equals to CD is 1 and CE is 2/3. So in total, DE equals to 1 minus 2/3. 1 minus 2/3 is third. So we found out that DE equals to third. DE equals to third. Here DE equals to third. So DE equals to third, C equals to 2/3, and CD equals to 1. And what is the value of OE? What is the value of OE? OE equals to OD plus DE. I write it down. So OE equals to OD plus DE. OE equals to OD plus DE. But we've already found out that OD is 1 and DE is third. So in total OE equals to 1 plus third. 1 plus third is 4/3. OE equals to 4/3 units. We found out that OE equals to 4/3 units. So we can write here that OE equals to 4/3 units. So in the next step, we will join together points O and B by a straight line. What is OB? OB, it is actually the radius of the semicircle, that is to say it equals to 4 units. OB equals to 4 units. And we will find out the size of angle OEB, the size of this angle. We will find out in this drawing that is clearer, it is more clear. We will find out the size of this angle, angle OEB, angle OEB. We have a rule that says that the sum of the angles on one side of a straight line equals to 180 degrees, and CO, it is the radius of the middle circle, therefore it is absolutely a straight line. CO is a straight line. So if we focus on this side of the straight line CO, at point E, the sum of its angles must be equal to 180 degrees. So what we have on this side of CO at point E, what we have, it is actually here we have 90 degrees plus this angle that is actually angle OEB. So the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees. Okay, according to the rule that I mentioned. 90 degrees plus the size of angle OEB must be equal to 180 degrees. Here we will subtract from this equality 90 degrees, and we will get that angle OEB equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle OEB is a right angle. It equals to 90 degrees. So here angle OEB, it is a right angle. So if angle OEB is a right angle, then triangle OEB is a right triangle because it has one angle that equals to 90 degrees. So I will draw again the right triangle OEB, and we will find out the length of side EB. Okay, we already know that OB is the radius of the semicircle, therefore it equals to 4 units. So I draw again the right triangle OEB. We have already found out that OE, side OE equals to 4 over 3 units, and OB, it is the radius of the semicircle, therefore it equals to 4 units. The only thing that is left to find is to find out the length of side EB of the right triangle OEB. So according to the Pythagoras theorem, in the right triangle OEB, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is OB. Therefore, the square of the hypotenuse is OB squared, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OE squared plus EB squared. So I will repeat again. According to the Pythagoras theorem, in the right triangle OEB, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB square equals to OE square plus EB square. But we know that OB equals to 4 units, therefore OB square will be equal to 4 square. 4 square is 16. So 16 equals to OE equals to 4 over 3. So OE square will be equal to 4 over 3 square plus EB square. Okay, again, OB square is 16, OE square is 4 over 3 square, and EB square is EB square. 4 over 3 square is 16 over 9, so I'll write it down. So 16 equals to 16 over 9 plus EB square. Here we will subtract 16 over 9 from this equation number 4, and we will get that 16 minus 16 over 9 equals to EB square. Here we will multiply 16 by 9 and then we will divide it by 9 in order to have a common factor with minus 16 over 9. So 16 times 9 over 9 minus 16 equals to EB square. Here 16 times 9 minus 16 is 16 times 8, so I will write it down. We will get that 16, according to equation number 4, 16 times 8 over 9 equals to EB square. Here it is EB square equals to EB square. So here we will take a root out of this equation, equation number 4, and we will get that EB equals to, according to equation number 4, EB equals to the square root of 16 times 8 over 9. We know that 16 is 2 times 8, so we will substitute 16 by 2 times 8 in this equation, equation number 4, and we will get that EB equals to 2 times 8 over 9. So the square root of 8 times 8 is 8 and the square root of 9 is 3, so I will write it down. In total we will get that EB equals to 8 over 3 times square root of 2 units. So we found out that EB equals to 8 over 3 times square root of 2 units. In the next step, we will prove that those two right triangles can go into each other. We will prove that those two green right triangles can go into each other. So I will draw those two right triangles again and we will prove that they can go into each other. So we will prove that those two right triangles, triangle OEB, can go into triangle OEA. First of all, we know that AO equals, or OA equals to OB equals to 4 units. The hypotenuses can go into each other. OA equals to OB equals to 4 units. They are the radiuses of the semicircle. And we also know that OE is a common side, it belongs to both triangles, so we can write down that OE equals to OE is a common side. So by proving those two things, that the hypotenuse and the perpendicular OE congruent in both triangles, we actually proved the triangle OEA, this triangle is congruent, this is the sign of congruent, to triangle OEB, and those two triangles congruent to each other according to rule number 5. So what is rule number 5? Rule number 5 states that if the hypotenuse and the perpendicular in one triangle, congruent to the hypotenuse and the perpendicular in another triangle, then those two right triangles congruent to each other. So I will repeat on rule number 5 again. According to rule number 5, if the hypotenuse and the perpendicular in one triangle congruent to the hypotenuse and the perpendicular in another triangle, then those two right triangles congruent to each other. And we actually proved that the hypotenuse OB and the perpendicular OE in the right triangle OEB congruent to the hypotenuse OA and the perpendicular OE in the right triangle OEA. Therefore, we proved that those two right triangles congruent to each other according to rule number 5. And from the fact that those two right triangles congruent to each other, we will conclude that AE equals to EB. We will conclude that AE equals to EB. We will conclude that AE equals to EB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two right triangles congruent to each other, therefore the corresponding sides AE and EB will be also equal to each other, which is to say AE equals to EB. And what is the value of AB? You can see from the drawing that AB equals to AE plus EB. AB equals to AE plus EB. So you can see from the drawing that AB equals to AE plus EB. But we already proved that AE equals to EB, so we can substitute AE in this equality by EB. So we'll do it and we'll get that AB equals to EB plus EB. that is to say AB equals to 2 times EB. And we have already found out that EB equals to 8 over 3 times square root of 2 units. So in total we will get that AB equals to 2 times 8 is 16. So AB equals to 16 over 3 times square root of 2 units. Or in terms of numbers, AB equals to 7.54 units. Okay, here AB equals to 16 over 3 times square root of 2 units, so in terms of numbers, AB equals to 7.54 units. We'll see it in the drawing itself, that chord AB, the length for chord AB is equal to either 16 over 3 times square root of 2 units, or in terms of numbers, the length of chord AB equals to 7.54 units. Okay, so now I will summarize the lecture. Okay, so actually we wanted to find out the length of chord AB. And we have here a semicircle, and inside the semicircle we have 3 circles. Those 2 small circles are identical, and the middle circle is tangent to the semicircle at point O. Point O is the center of the semicircle, and point C is the center of the middle circle. But we know that PQ, that is the diameter of the semicircle, equals to 8 units, and the diameter is twice as large as the radius. So if PQ equals to 8 units, then the radius PO will be equal to 4 units. Likewise, the radius QO of the semicircle will be equal to 4 units, and the radius OX of the semicircle will be equal to 4 units. But OX is not only the radius of the semicircle, but it is also the radius of the middle circle itself. But it is also the diameter of the middle circle itself. OC is the diameter, OX is the diameter of the middle circle. And if the diameter OX equals to 4 units, then the radius of the middle circle, CX, will be equal to 2 units. So the radius CO of the middle circle will be equal to 2 units, and the radius CY of the middle circle will be also equal to 2 units. Then we connected together points M and C by a straight line. MC is the distance between the centers of those 2 circles, and when you have an external notch between 2 circles, then the distance between their centers is equal to the sum of the lengths of their radiuses. That is to say, in this case, MC equals to R plus 2 units, because R is the radius of the small circle, and 2 is the radius of the middle circle. That is to say, therefore, MC equals to R plus 2. Then we defined the center of the middle of this small circle as point M, and we defined the touching point of tangent PQ with this small circle is point N. Point N is also the point of tangency of tangent PQ with this small circle. And we join together points M and N by a straight line. MN is the radius of the small circle. And we have the radius of the small circle that is drawn to the point of tangency, that is to say, it is drawn to point N, that is the point of tangency. Therefore, the tangent PQ will be perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we have the radius CO of the middle circle that is drawn to the point of tangency, that is to say, it is drawn to point O, that is the point of tangency of tangent PQ with this middle circle. Therefore, the tangent PQ will be perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle also will be equal to 90 degrees. then we, from point M, that is the center of the small circle, we draw perpendicular to CO. And the touching point between the perpendicular to CO is at point D, so this angle equals to 90 degrees and this angle also equals to 90 degrees. And then I draw again this quadrilateral MNOE and the right triangle CMD. Okay, this is the perpendicular MNOD or MNDO, and this is the right triangle CMD. And in the quadrilateral MNDO we have 3 right angles, but before that actually we have rule number 1, that corresponding angles between parallel lines are equal to each other. So we know that AB is parallel to PQ. Therefore, those two corresponding angles will be equal to each other. So this angle is 90 degrees. It will be equal to this angle that is actually angle CEY. CEY, yes. So according to rule number 1, this angle that is 90 degrees will be equal to angle CEY. Okay? So we found out that this angle CEY in the green triangle, is a right angle. Likewise, if we focus on the other side, here we know that AB is parallel to PQ, it is given us the question, therefore those two corresponding angles will be equal to each other. And this angle equals to 90 degrees. Therefore, this angle that is actually angle CEB will be also equal to 90 degrees, according to rule number 1. So, we have this angle that is 90 degrees and it will be equal to the corresponding angle CEB. So we found out that angle CEB is a right angle according to rule number 1. That is to say, this angle CEB is a right angle. Then we have also rule number 2. According to rule number 2, the sum of the angles in any quadrilateral equals to 360 degrees. And if we focus on quadrilateral MNOD, it has 3 right angles, 1, 2, and 3. And according to rule number 2, the sum of the angles in quadrilateral MNOD must be equal to 360 degrees. That is to say, the sum of 3 right angles is 270 degrees, plus the size of this angle that we defined as angle X must be equal to 360 degrees, according to rule number 2. So, 270 degrees, the sum of 3 angles plus the sum of the 4th angle, that is angle X, must be equal to 360 degrees according to rule number 2. We subtracted 270 degrees from this equality and we got that angle X equals to 90 degrees. So this angle is a right angle. It equals to 90 degrees. So we found out that all 4 angles in quadrilateral MNOD are right angles. When we have rule number 3 that states that any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral MDMNO as a rectangle. And we have also rule number 4 that states that the opposite sides of a rectangle are equal to each other. And we know that MN equals to R, it is the radius of the small circle. And according to rule number 4, MN equals to DO, because those sides are opposite sides and they are equal to each other according to rule number 4. So Mn equals to dO, but we have already found out that Mn equals to R. Mn equals to R. So from this equality we will conclude that dO also equals to R. So here dO also equals to R. Then we calculated the value of CD. First of all, CO is the radius of the small circle, that is to say it equals to 2 units, and DO is R. So in total we found out that CO minus DO equals to CD. Okay, CO minus DO equals to CD, but we know that CO equals to 2 units and DO equals to R, so in total we found out that CD equals to 2 minus R. So we wrote here that CD equals to 2 minus R. And we have already found out that MC equals to R plus 2. So we focused on the green triangle CDM. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is MC, that equals to R plus 2, so MC square will be equal to R plus 2 square. CD equals to 2 minus R, so CD square will be equal to 2 minus R square. MD equals to MD. So we open the brackets in equation number 1. In both sides, R plus 2 square equals to R square plus 4R plus 4. 2 minus R square equals to 4 plus R square minus 4R plus MD square. Here we have R square in both sides of equation number 1, so R square will get cancelled. And we have also 4 on both sides of equation number 1, so 4 will get cancelled. And what is left from equation number 1 after we cancel those expressions, what is left in this side, it is actually 4R. And on the other side, what is left is minus 4R plus MD square. We added to equation number 4, 4R. So 4R plus 4R is 8R. And 4R minus 4R is 0. So in total we got that 4R equals to MD square. Here we took a root of equation number 1. And we found out that MD equals to the square root of 8R. MD equals to the square root of 8R. And we know that 8 equals to 4 times 2. So we substituted 8 by 4 times 2. And so in total we got that MD equals to the square root of 4 times 2 times R. The square root of 4 is 2. So in total we got that MD equals to 2 times square root of 2R. So MD equals to 2 times square root of 2R. And we have rule number 4 that states that the opposite sides of a rectangle are equal to each other. That is to say MD equals to NO. MD equals to NO from one side, but from the other side we have already found out that MD equals to 2 times square root of 2R. So from this equality we will conclude that NO also equals to 2 times square root of 2R. So we wrote here that NO will also equal to, it is also equals to 2 times square root of 2R. And then we join together points O and M by a straight line. And we found the value of OM. Here we also join together points O and M by a straight line. Then we join points AM and A by a straight line. AM is R. OA is the radius of the semicircle, that is to say it equals to 4. So OM equals to OA minus AM. OM equals to OA minus AM. But we know that OA equals to 4 units. AM equals to R. So in total we found out that OM equals to 4 minus R. So we can write here that OM equals to 4 minus R. We have already found out that NO equals to 2 times square root of 2R and R equals to 1. So we implemented the Pythagoras theorem in the green right triangle M and O. According to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is MO, so the square of the hypotenuse is MO square, and it equals to MN square plus NO square. We have already found out that MO equals to 4 minus R. So if MO equals to 4 minus R, then MO square will be equal to 4 minus R square, and M equals to R, so NM square will be equal to R square, and O equals to 2 times square root of 2R, and NO square will be equal to 2 times square root of 2R square. We open the brackets on both sides of equation number 2. 4 minus R square equals to 16 plus R square minus 8R. Here we have R square plus the square of 2 times square root of 2R is 8R. Here we have R square on both sides of equation number 2, so R square will get cancelled. After we cancelled R square, we added 8R to this equation number 2. 8R minus 8R is 0, so here we left 16. And here we have 8R plus 8R is 16R. So in total we got that 16 equals to 16R. We divided equation number 2 by 16 and we got that R equals to 1 unit. So we found out that R equals to 1 unit, R equals to 1 unit, and CD that equals to 2 minus R, and R is 1, so CD actually equals to 2 minus 1, that is to say CD equals to 1. Okay? But if CD equals to 1, so here actually we focused on the right triangle CYE and on the right green triangle CYE and on the right triangle CDM, we actually proved that those two right triangles are similar to each other. Why they are similar to each other? Because first of all, we have those two angles, they are both right angles, therefore they are equal to each other. So angle CY equals to angle CDM equals to 90 degrees. They are both right angles, and we also have this angle that is a common angle. It belongs to both triangles. Angle C belongs to the green triangle CYE, and angle C also belongs to the right triangle CDM. So we can write down that angle C equals to angle C as a common angle that belongs to both triangles. And we also have those two angles that are equal to each other, that is to say angle CYE equals to angle CMD according to third angle theorem. And what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And we found out that those two angles, the right angles, they are equal to each other, so those are the first pair of angles that congruent. And angle C, it is a common angle, so angle C equals to itself. So this is the second pair of angles that congruent in those two triangles. Therefore, if we have two pair of angles that congruent to each other, then the third pair of angles must also congruent. That is to say, those two angles must be equal to each other. So that is the third angle theorem. So in this way, we actually proved that all three angles in the right triangle, green triangle CYE equals to all three angles in the right green triangle CDM. Therefore, we proved that those two triangles are similar to each other according to angle similarity rule. So we actually proved that triangle CEY similar to triangle CDM according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if we prove that all three angles in one triangle congruent to all three angles in another triangle, then you actually proved that those two triangles congruent to each other according to angle similarity rule. And from the fact that triangle CYE is similar to triangle CDM, we will conclude that CE over CY in triangle CYE equals to CD over CM in triangle CDM. So CE over CY. CY is 2 equals to 2 units. It is the radius of the middle circle. CD equals to 1 unit. So CD equals to 1 unit, and CM equals to R plus 2 and R equals to 1. So CM equals to 1 plus 2, that is to say CM equals to 4 units. CM equals to 4 units, so in total we got that CE over 2 equals to 1 over 3. Here we multiply the equation number 3 by 2 and we got that CE equals to 2/3. So here CE equals to 2/3 and CD equals to 1 unit. So DE will be equal to CD minus CE. Okay, DE equals to CD minus CE. So DE equals to CD, that is 1, and C minus CE, that is 2/3. So DE equals to 1 minus 2/3. 1 minus 2/3 is third. So we found out that DE equals to third. Here DE equals to third. DE equals to third, C equals to 2/3, and CD equals to 1. So in the next step, we calculated the value of OE. What is the value of OE? You can see from the drawing that OE equals to OD plus DE. OE equals to OD plus DE. OD equals to R, it is equals to 1, the radius of the small circle. DE, we already found out that DE equals to third. So in total OE equals to 1 plus third, that is to say OE equals to 4/3. OE equals to 4/3. OE equals to 4/3 or 4 over 3 units. Then we join together points O and B by a straight line. OB is the radius of the semicircle, it equals to 4 units. Then we calculated the size of angle OEB. The size of angle OEB, the size of this angle. We know that CO, that is the radius of the middle circle, is absolutely a straight line. And we have a rule that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on this side of the straight line CO, the sum of its angles at point O must be equal to 180 degrees. So if we focus on point E, this angle is 90 degrees, plus this angle that is angle OEB, it must be equal to 180 degrees according to the rule that I mentioned. 90 degrees plus the size of angle OEB must be equal to 180 degrees according to the rule that I mentioned. Here we will subtract 90 degrees from this equality and we will get that angle BEO equals to 90 degrees. So we found out that this angle BEO equals to 90 degrees. And if angle OEB equals to 90 degrees, and if angle OEB equals to 90 degrees, then triangle OEB is a right triangle. So I draw again the right triangle, triangle OEB. That is a right triangle. We know we already found out that OE equals to 4 over 3 units, and OB is the radius of the semicircle, that is to say it equals to 4 units. And the only thing that is left to do is to find out the length of side EB. And we will find out the length of side EB according to the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say OB square equals to OE square plus EB square. OB equals to 4, so OB square is 4 square. 4 square is 16. OE equals to 4 over 3, so OE square equals to 4 over 3 square. Plus EB square. Here 4 over 3 square is 16 over 9. So in total we got that 16 equals to 16 over 9 plus EB square. We subtracted 16 over 9 from this equation, equation number 3, and we got that 16 minus 16 over 9 equals to EB square. Here we multiplied 16 by 9 and then we divided it by 9 in order to have a common factor of minus 16 over 9, and we got that 16 times 9 over 9 minus 16 equals to EB square. 16 times 9 minus 16 is 16 times 8. So 16 times 8, 16 times 8 over 9 equals to EB squared according to equation number 4. We took a root out of equation number 4 and we got that EB equals to the square root of 16 times 8 over 9. 16 is 2 times 8, so we substituted 16 by 2 times 8 and we got that EB equals to 2 times 8 over 9. The square root of 8 times 8 is 8 and the square root of 9 is 3. So in total we got that EB equals to 8 over 3 times square root of 2 units. Okay, then we proved that those two right triangles can go into each other. Those two right triangles can go into each other. And they actually can go into each other. I copied again, I drew again the two right triangles. We proved that those two right triangles can go into each other. Why they can go into each other? Because first of all, OA equals to OB equals to 4 units, and OE equals to OE, it is a common side that belongs to both triangles, so OE equals to itself. So by proving those two things, we actually proved that triangle OEA is congruent to triangle OEB according to rule number 5. And what is rule number 5? Rule number 5 states that if the hypotenuse and the perpendicular in one triangle congruent to the hypotenuse and the perpendicular in another triangle, then those two right triangles can go into each other. And we actually proved that the hypotenuse OA and the perpendicular OE in triangle OEA can go into the hypotenuse OB and the perpendicular OE in triangle OEB. Therefore, we proved that those two triangles can go into each other according to rule number 5. And from the fact that those two triangles can go into each other, we will conclude that AE equals to EB according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides AE and EB, now they will be equal to each other, that is to say AE equals to EB. Then what is the value of AB? From the drawing you can see that AB equals to AE plus EB. AB equals to AE plus EB, but we already found out that AE equals to EB, so we can substitute AE in this equality by AB. We substituted AE by EB and we got that AB equals to EB plus EB. That is to say AB equals to 2 times AEB. And we have already found out that EB equals to 8 over 3 times square root of 2 units. So in total we found out that AB equals to 2 times 8, it's 16 over 3 times square root of 2 units. So AB equals either to 16 over 3 times square root of 2 units, or in terms of numbers, AB equals to 7.54 units. I will repeat again, in the drawing itself, we have chord AB. This chord AB equals to either 16 over 3 times square root of 2 units, or in terms of numbers, the length of chord AB equals to 7.54 units. Okay, thank you very much.